In this demo, we're going to take a little bit different tack. Instead of using our configuration to download directly to the controller card, we're actually going to create an Arduino program from the configuration and then have Arduino in the Arduino environment download the program to the card. So we're going to start from this point. After installation of the configurator and all the other software on your hard drive, you'll find a directory here called RRCS files. And in that directory, there's a number, or folder if you like that term better, there's a number of subfolders. One of them is called Arduino programs. And if you open that up, you'll see what we have here is example programs that were previously generated. There's one here called Demo2 Test, and I'm going to erase that right now because we're going to recreate that at this point. So Demo2 Test is gone. When we recreate the program for the Arduino environment, it will end up in its own folder here in this Arduino program subdirectory. This other folder called configurations is where our actual configuration files are stored. And if we look in there, you'll see here's the configuration files all listed. Again, these are demo files that come with the system. But the ones that we created in previous demos, configuration 1, 2, and 3, are sitting in here right now. This folder here contains the actual configuration software. And we're going to open that in a minute. And then we have some other folders for documents and some other software that gets incorporated, and we won't look at those, but that's part of the system. What I'm going to do is open the configurator, and I'm going to run the configurator just by clicking on this configuration exe. And this probably looks familiar from previous demos. We're not going to connect to the S3 because we're going to let the Arduino environment connect to the S3 and actually download the program to it. So we're going to continue without a connection. And what I'm going to do is I'm going to reload demo number 2, which was configuration 1. And as you recall, if I go down here and I look at the logic for signal number 1 in this demo, you'll recall that we had this fairly complex amount of logic that was generated the first time we did the demo, not the simplified version. We're going to stick with the complex version for now. And all the other devices and so on that we created during that demo are all here. Now, once we have this loaded, if we want to create an Arduino program from it, all we have to do is click on Generate Program. And this screen pops up and it says, give this project a name. So I'm going to call it, in this case, Demo2, let's call it Trial 2, because the first time I did it, it didn't get recorded properly. The author, I'm going to put my initials, version number if you'd like one. License code, every copy of this software has a license code. In this case, I'm just going to use a dummy code, which is CS1111. And then we can put in the description of the program. I'm just going to call this demo of, let's call it demo of creating an Arduino program. And we click generate and save, and just like that, this message pops up. It says program file, Arduino programs demo2 trial2.ino was generated. And I'm going to exit from the configurator environment. I'm going to go back to Arduino programs, that subdirectory, and And sure enough, here's our demo 2 trial 2 folder. And in that folder, we have the INO file with the program that was just generated. So I'm going to click, I'm going to load up the Arduino environment using that as my file. And as you can see, there's a message here and a comment at the beginning saying program generated by the S3 configurator from configuration number 1. Name demo 2 trial 2 version 1, date and time created, which was just now, a minute ago. Author and comment, demo of creating an Arduino program. So that part was generated from the information we entered when we did the configuration build. And then the rest of this is all the code, drivers, communication software, and everything else that's needed to run the system. And we're not going to look at all of that because it's about 6,000 lines of code. But if we come down near the end here, we'll come to a part that says eventually generated function to load the configured object tables. And what this does is for every object that we created in our configuration, it loads that information about that object into a table or an array, if you will. So you'll see here's one for a card. We have the master card, which is card number 1. Here's 2 for the 2 turnouts that were in this configuration. Here's a generated code to create the signal that we defined. It's signal number 1, and it's a 3-light signal. And we created some indicators. You'll remember that was something if you looked at the add-on demo, I created indicators at the last minute so that we could see the state of the push buttons. These are the indicators that I created, panel indicators, number 1, 2, and 3. You'll notice there's some things here that are blank because we didn't create any traffic lights or chase lights. We did create a bunch of sensors, and these are push on-off buttons. You'll note there's number 1, 2, 3, number 7, and 8 here, as was defined in the demo. Moving down a little further, we can see end of loading tables. Now here's another function that's created called do logic. And this is a standard function that's called every cycle through the big loop in the Arduino environment. And what it does is actually creates the logic that we defined. For example, you'll see here signal number 1 logic. Signal number 1 state equals D. This is setting the default value. The first thing it does is set the default value if there is one. And then if any of the following statements are true, that default value will be overridden. So in this case, the logic line, first logic line, as you recall, is signal is red when input 1 is on and turnout 1 is reversed. And that translates to this if statement. If sensor 1 state is on and turnout 1 commanded state is reversed, signal number 1 state is red, and go to end signal 1, which means, excuse me, if this signal or this state is true, none of the rest of the logic for this signal will be carried out. It'll skip over all the rest of it, and it'll skip on down to end signal 1 right here. Likewise, excuse me, got a little frog in my throat here. Likewise, you can see here logic for the indicators. It says their default is dark and they come on when the sensor or input is on. And going down a little further, you'll see the logic for the turnouts that we created that says they're on when the sensor corresponding push button is on. And that's it. All the logic that we created by the configuration is all here, and it all runs on every cycle. So we have a generated program here. You can see it's about 6,000 lines long. And all we have to do to get that into our controller is click the compile or download button, and the Arduino environment will create the program. And when it's all done, you'll be able to see that it just got downloaded and the controller was rebooted. And you'll see down here information about the memory usage. You'll see the code was 27,000 bytes, data 2,400. And in case you're concerned about all this code taking up space, you'll note that there's a lot of memory left over on this card, which has actually like 2 million bytes of memory. The chances of ever filling it up is next to nil in our lifetime. So the program's downloaded. Now I'm going to stop what I'm doing here, and I'm going to switch over to the camera view so we can actually see the program running on the S3 card itself. There's a couple other things I wanted to mention before we look at the actual operation. One is just to look at this last line of logic here for our green signal, and just note that for every term that is in the logic, and there can be up to 8 of them, you'll see there's a corresponding statement that's part of this big if statement here. So we have actually 5 terms in the logic here. We have 5 different if conditions, and they're all connected together with an and. The other thing I wanted to mention while we're looking at this is if we scroll down to the very end here, past the indicator logic and past the end of the normal logic, you'll see there's a function here called do user logic. This is a point at which, if you have a mind to, you can insert your own code into the program. And this function will be called after this other logic is completed, but before any actual outputs are sent to the devices. So if you have a mind to add some logic of your own, or add anything at all that you need into the program, here is a hook that you can use to do that. And of course, if you're willing to try it, you can make other modifications to the code anywhere you like. The last thing I wanted to mention is why would you want to do this? It's basically if you have an interest in working in the Arduino environment and have the skills to do so, this can build you a framework of a program to do a lot of things, and then you can, using your own logic or your own programming skills, add anything to this that you want. But it basically gives you a lot of functionality to start with, and you can extend it. Okay, now we're going to look at the actual operation, and you'll notice it's pretty much identical to the way it was before. Okay, so here's our test setup as it was before, except that we've now downloaded the program that we compiled with the Arduino environment. And as you recall, our signal here is an approach signal, so right now it's not lit. If I press block number 1, I get the indicator that block number 1 is occupied and the signal is green. And then if I, for example, change one of the turnouts to a different position, it goes from green to red. Switch it back. If block number 3 is occupied, the signal goes to yellow, or if block number 2 is occupied, it goes to red. And if both of them are clear, it goes back to green. So that's basically the identical functionality to what we had. It's just that in this case, the program is all the logic is compiled into the program.